Now for part C, I would just like you to remember that lambda A then multiplies P, which we found to be P naught E. We have it up there, P. And then I'm just going to say that the top one was minus lambda A plus lambda C times T. That's the same as that number that we have over here. So why did I do that? Well, now I notice that this is separable, so I can say dA is equal to lambda A P naught e to the minus lambda A plus lambda C times T dt. And now I can take the integral of both sides. Okay, and now that I take the integral, I get that A of t with MATLAB, so I would put this in MATLAB just to be sure that you get it correctly, is equal to lambda A over, and there's a negative in front, lambda A plus lambda C P naught times e to the minus lambda A plus lambda C times T plus C2. Now, you might ask, where did this come from? Well, think about it. If this is the derivative, we want to take the integral. So if this is the derivative, then when we take the derivative, we need to get this. So if I take the derivative of this, I'm going to have this that multiplies in front. And that means that it's going to have to be canceled out by whatever is over here. That's why we have it in the denominator there. And then we apply the initial condition. So 0 is equal to minus lambda A over lambda A plus lambda C times P naught. This becomes a 1 because it's multiplied by T, which is 0, plus C2. So we get the C2 is equal to lambda A over lambda A plus lambda C times P naught. And we can substitute it back in, and we get that A of t is equal to lambda A divided by lambda A plus lambda C with the negative, P naught E to the lambda A plus lambda C times T plus lambda A over lambda A plus lambda C times P naught. And this is going to be our answer to part C, right? This is going to be our answer to part C. Now, if we wanted to, we could factor out this term over here and write it multiplied by e plus to this power plus 1. Now that we have this, we're going to substitute P also in C, and we're going to do the similar process. So we have that dC dt is equal to lambda C times P. Well, lambda C we can rewrite, and then P0 e to the negative lambda A plus lambda C. So P naught e to the negative lambda A plus lambda C times T, that was the T part. I can write this dt informally to this side, take the integral, and I would get C of t is equal to, well, again, that stuff is going to have to be canceled out. So it's going to be lambda C, which is pulled out because it's a constant, minus lambda A plus lambda C, P naught, and then we have e to the negative lambda a plus lambda c times t plus c3. With the initial condition, 0 is equal to this whole business, lambda c p naught minus lambda a plus lambda c. This becomes a 1 equal to c3. So we can see, so plus c3. So we end up that with c of t equaling to what we have above, which is this. So I'm just going to copy, paste, copy and paste. But instead of c3, I'm going to write lambda c p naught divided by lambda a plus lambda c. Okay, and now once we have that, we want to find what? So let me box this answer. We want to find the percentage of an initial amount of P naught that decays into AR4 over a very long period of time. The percentage of P naught that decays into argon. Well, if I look at this, I have a P naught here. And so what I want to do is I want to see, as we go to infinity, what happens. Well, as we go to infinity, this term is, which has the t, is a transient term. It'll go to 0. Well, will it go to 0? Let's see, as we go to infinity. Oh, look at that. I'm missing a negative here, because otherwise it would go to infinity. But that wouldn't make a whole lot of sense. We can't get an infinite amount of something that was finite. So this term is transient, will go to 0. So as t goes to infinity, we can say that a, as t approaches infinity, becomes lambda a over lambda a plus lambda c of P naught. So this part is the percentage of the original amount. So we have 0.581 times 10 to the negative 10 and 0.581 times 10 to the negative 10 plus 4.962 times 10 to the negative 10. And if we do that, we get 0.105 P naught, which is 10.5% of P naught. So that's our answer to part D. And now we can do the same with C of T. Determine the percentage of the initial amount of K40 that decays into Ca, calcium 40. Oh, so this was calcium. I think I've been calling it carbon for this whole time. So disregard when I did that. And so as C of T goes to infinity, here we also get lambda C P naught over LA plus LC. But do we really have to do this? Well, because if it only decays into these two things, then what's left decays in calcium 40. So that's going to be 100% minus what decays into argon, which is 89.5%. And so this should match that percentage. So let's check. LC is going to be 4.962 times 10 to the negative 10 divided by 0.581, and I'm going to group them, plus 4.962 times 10 to the negative 10, so these can cancel out. And what do we get? We get 0.895, which is indeed that one. So I hope you enjoyed this one, and I'll see you next time.